Okay, so that completes our derivative process. Now we're just trying to rearrange things to try to get dy dx by itself. Sine of negative pi is same thing as sine of pi. That's going to wipe out to be 0. So I have -6. Cosine of 3 pi is same thing as cosine of pi, which is a -1. -1 times negative pi will be a positive pi.
Same thing.
Yeah, that's let's see, -2xy plus, but then the bottom signs will have to be different as well. Do you have positive
Yeah.
and positive? Okay, that works. So you should get the same slope, one of these options here when you clean up. Okay, any questions with 3? All right, number 4, related rates, parts A and B, just Pythagorean theorem. Sorry, part A is Pythagorean theorem, and part B is where we are involving trig and theta. So, right, so person X and person Y are walking on straight streets that meet at right angles. Y travels south, and person X travels east, moves away. The part A, we're not going to deal with theta. We're just dealing with Pythagorean theorem here. Find the rate at which the distance z between person X and Y is changing when Y is 10 meters from the intersection and X is 20 meters from the intersection. So we're trying to find dc dt, but get the derivative going here. Y travels south at 2 meters per second. Any adjustment that we need to make here? Negative, yeah, because as Y is traveling south, he's causing that vertical side of the triangle to be decreasing. As X is getting further and further away from that intersection, he's causing that base of the triangle to increase, so +1. Z, we can use Pythagorean theorem, and then we can plug everything in to solve for dc dt. Wait, my bad. 400 plus 1. 500. All right. Any questions? Part A. Okay, part B. At what rate is angle theta changing at the same moment? Yes.
Yeah. -2.
Yeah.
Oh, sorry.
You plug in 20 for Y. For 2Y.
Oh, my bad. It should be 2 times 10, right? My bad. Thanks for that correction. Y is 10. Yeah, sorry. All right, ends up being 0 then. Now, it just so happens that we know that Z is changing. It's not like the ladder problem where it's going to stay constant. It just so happens that at this moment in time, the decrease changes to increase. And so that's why it's that interchange where you're going to get 0. But if it's any other moment in time, it would end up giving you a negative or positive value. So just want to make sure we understand that it does end up being 0, but it's different than the ladder problem. Okay, so this is changing, but it just so happens that it's at that point where it decreases, but then changes to increase. Okay, sorry about that. Is that what you guys got? 0? All right, thanks. Okay, part B, at what rate is the angle theta changing? Now, I'm going to draw the diagram for you, so you don't have to guess where theta is. But theta is, in this case, is in the bottom corner of the triangle. You can, in this case, you can use any trig function, sine, cosine, or tangent, because you have all the data that you need from all the variables. I'm just going to choose tangent, but you can choose others and you'll get the same thing. But if you want to just do tangent with me just to match up our work, but if you have more data than you need, then you can use any trig equation to still get the same answer. Right, so if we're dealing with, if we're trying to find d theta dt, we're always creating a trig equation first, either sine, cosine, or tangent. And because x's and y's, these lengths are still changing over time. None of these are constants. Because none of these are constants, we have to, any trig equation we use they all have to remain or begin as variables. Okay. Only when you are convinced that a side is not changing throughout the entirety of the problem, then you can replace that that side with a constant value. But in this case, as we visualize the problem, move beginning from time t equals 0 to moving forward, we can imagine every side length is changing as time passes. Okay, so I'm going to choose tangent. Because my right side is purely in terms of variables, I have to go through quotient rule. There's no way for me to avoid it. I mean, I could avoid it by bringing it up using product rule, but I just think it's a little bit cleaner just to go through quotient rule. But we can't just rely on power rule. Okay, so remember, we're still doing related rates, so every time we find the derivative, we're expecting d theta dt to show up, we're expecting dy dt to show up, and we're expecting dx dt to show up. So tangents, derivative. Okay, f prime g minus fg prime. So if you look, we have everything, mostly everything accounted for. We have dy dt, we have x, we have y, we have dx dt, we have x squared. We're looking for d theta dt, but the one thing that's standing out that requires more work is trying to find secant squared theta. So I want to keep reminding ourselves that we're not looking for theta. We're trying to find a replacement for the entirety of that trig function. So to do that, we're going to draw a second triangle and try to figure out the ratio to replace that secant theta with. So here's my second triangle, just to help me with figuring out my ratio. So this moment in time, I know x, y, and z. So I'm going to just fill them out. X is 20, y is 10, and z is 10 root 5. Right. What is secant of theta at this moment in time? Good. Hypotenuse over adjacent. We know cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. So we know secant of theta will just be 10 root 5 over 20. If you want to reduce it, you can make it root 5 over 2. Right, so now we're going to take this, put it in for secant, make sure we square that, replace all of our d over dt and x's with numeric values that we found, and then we're just trying to get d theta dt by itself. All right, try that. All right, so I just took that reduced version of secant theta, put it in for that left side, root 5 over 2 squared, which is really 5 over 4. Replace all the right side with all the terms that I had from part A. Did some cleanup here. I made it negative 50 over 20 squared. Dividing by 5/4, the same thing as multiply by 4/5. If you leave your answer like this, it's fine. I just put it into the calculator and I got negative 1/10. Your units of measure is never degrees, it's always radians per time unit. So we want to keep reminding ourselves that we're not looking for theta, we're looking for the entire trig ratio to replace into the function. You can expect one problem on your test to look like this. Any questions? Okay. Next page. All right, we're going to do a full curve sketching problem here. So we're going to find and we're going to find f prime, create the sign line for f prime, f double prime, create the sign line for f double prime, and then list out all of our characteristics and include because statements. Does anybody still need to look at page 3? Okay. All right, so find all ordered pairs or relative max, relative min, POI, points of inflection, concavity. So let's just move into first derivative test. Let's find f prime and gather our data from f prime. So I'll work alongside you guys. You guys try it. I plug pi into the derivative. Cosine of pi is -1. 2 negatives makes positive, so my interval there is positive. 3 pi in for x. 3 pi has the same behavior as pi. We still get negative, so 2 negatives makes positive. F double prime. One goes to 0, cosine becomes negative sign, but 2 negatives makes positive, so. No. Oh, I plug pi back into f prime because I want to gather slope behavior. slope yet.
I think you said they would always.
No, you're right. On the quiz, I'll make the graph more predictable, but this is one of those where it's not, the slope is not as predictable as, but we can test it and we can see that the slope, but yeah, on the quiz, I'll make it more where you're probably gonna be expecting relative max, relative min.
You said you plugged it back into the original alphabets.
Right, probably.
F prime. If I'm gathering slope behavior, it's always F prime. If I'm eventually looking for physical points on the graph, then they go back to the original function. But right now, we're just gathering slope information. Okay, good. Any other questions with F prime? All right, F double prime. So I'm extending all the way out to 4 pi because that's my interval. Okay, I'm testing values in between to gather concavity information. Into F double prime. So sine of pi over 2 is positive. We know that corresponds with concave up. Sine of 3 pi over 2 is negative, concave down. 5 pi over 2 is similar to pi over 2, which will give me positive. And 7 pi over 2 is essentially the same behavior as 3 pi over 2. They're just 2 pi apart from each other. So negative. So even though there is no relative max, relative min, our curvature will still display points of inflection on our graph. Okay, relative extrema, no relative max, relative min because there's no change in signs. Okay, we do have points of inflection at pi, 2 pi, and 3 pi. If I want to find the order pair, I'm going to plug this back into the original equation. So the order pair at pi is pi minus sine of pi, which is just pi. Sine of 2 pi is still 0. 3 pi is also 0. So it's just going to be y value for pi will be pi. The y value for 2 pi will be 2 pi. Y value for 3 pi will be 3 pi. Okay. And then on the test, I'm also asking you to provide justification. So provide because statements for relative extrema, for points of inflection, for concavity. Here we don't have to provide them since we don't have any, but here will be because F double prime changes signs. Okay. List out your intervals of concave up. Concave down. Okay, if I want to find absolute max, absolute min, that's applying what? What theorem is that? Extreme value theorem. So extreme value theorem says test endpoints and critical points. So you're only picking that off of your F prime. You're not picking off of F double prime. So there is no critical points, right? There is no relative extrema, so we only need to test 0 and 4 pi, since those are the only candidates. So I'm gonna find the order pair at 0 and find the order pair at 4 pi. Back into the original function. 0 in for x, I get 0 minus sine of 0, which is 0. Plug 4 pi in for x, I get 4 pi minus sine of 4 pi, which is just 4 pi minus 0 is 4 pi. And between these 2 points, one of them will be absolute max, the other will be absolute min. So 0 is a lower, and max is the highest.
We don't have to give the points. Just,
Yeah, just the y value. Yeah.
We know that if it's like all the way increasing, that like 0 would obviously be less than the minimal.
Yeah, that's right. Yeah. So right. But we're just applying extreme value theorem here, which we're just stepping through that process, testing endpoints and critical points, and yeah. And then once we find those endpoints, that's all we need to test. Okay, let's sketch our graph. We have all the order pairs that we need. We have the 2 endpoints. We have all these points from points of inflections. So we should be able to plot a bunch of these points and then sketch the graph. One version, one draft is just seeing that the graph is going to rise. It's going to flatten out for a moment, but then continue rising. And then across these points of inflection, the graph is going to change its curvature. So I'm going to do this in 2 stages. I know I have 0, 0. I know I have 4 pi. 4 pi. And all these order pairs will just, I'm going to just name them in terms of pi to make it easy. And so all these middle points are just points of inflections. So my first draft is, I know my graph is going to be rising. It's going to flatten out at 2 pi, but then continue to rise. And then along the way, I can give it more curvature information. From 0 to pi, it's concave up. From pi to 2 pi, concave down. 2 pi to 3 pi, concave up. And concave down. Okay, so we finished our classwork that I'm going to check tomorrow, but we have a little bit of time. So let's see if we can get through 1 and maybe a little bit of 2. Yes.
Is there a chance they ask us for the f of, or what's it called? Second derivative?
Yeah, there's a point of inflection at pi, at 2 pi, and at 3 pi. So I made this concave up, concave down, concave up.
I was wondering if they're gonna ask us for another graph, like the.
Oh, no. Yeah, so you're not, with this, I'm not going to give you a derivative graph. You have to produce f of x and f double prime.
Okay.
Yeah, it's just going to be straightforward where I give you a function.
Okay.
And you're just going to be graphing f of x.
Okay.
Yeah, that's all you're going to graph on the test. Yeah. All right. So this is a related rates problem. Angle theta is increasing at a constant rate of 6 radians per hour. See if we can begin to assign some values to variables. What do you think? What can we assign that 6 radians per hour to? Good, d theta dt. You know, there's an increasing rate, radians per hour. You know, it can't be just a static value. It's a rate. So we know d theta dt, positive or negative 6. Positive because increasing, yeah. At what rate is the side of length x increasing? What are we looking for? Good, dx dt, yeah. It's talking about rate of change of x when x is 6 feet. All right, next up, we're going to find a trig equation to build. Which trig equation will allow us to hit all these 3 sets of information? Sine, yeah. Sine of theta is equal to x over 10. Okay. If you look at the right side here, there's no need for quotient rule since one side is showing us the constant. How can I rewrite this so that it'll be easy for us to do power rule with it? Rewrite this as what? Yeah, 1/10 x, it just feels cleaner. You're not staring at a number below the variable. It just feels like a number in front of the variable. Okay, so we're ready for our derivative. Every variable will get impacted by time. So let's do sine theta first. What's sine theta's derivative? Cosine theta times, yeah, d theta dt. Okay, good. 1/10 x becomes 1/10. But remember, every variable is impacted by time here, so time dx dt. Yeah. Okay, we have dx dt showing up. That's the variable we're looking for. We have d theta dt to plug in. And really the only thing that is left for us to worry about is figuring out what to do with that cosine theta. All right. And again, we're trying to replace the entire cosine theta. We're not trying to figure out a replacement for theta. Okay, so this is where we're going to create our second triangle to find a ratio that we can replace that cosine theta with. And when we create our second triangle, we're trying to fill in all these sides with numbers. So we know 10 is here. X is what? 6. And Pythagorean theorem tells us the third missing side must be what? 8. Yeah. Variation of 3, 4, 5 right triangle. So now we can read this triangle and say cosine of theta is equal to 8 over 10. If you want to reduce, you can. And get for this. Okay, so now everything that we need is available to us. We can just plug in and solve for dx dt. I want to just isolate that dx dt. I want to move that 1/10 over, dividing by 1/10, the same thing both ways by 10. I'm just going to reduce that to be 48. Okay, we'll pick up tomorrow. Let me get back your quizzes.
Like full practice, the practice.